Right, so as mentioned, I'm Benno Rice. Up until about February last year, I was doing sort of general Python-y, web-y kind of stuff with all sorts of interesting stuff involving telemetry and GPS units and fun like that. But I'd also been working on the FreeBSD project mainly as an amateur, just in my spare time for a while. I'd done enough stuff to get myself commit access. Funnily enough, when you pick up an iMac and when they were PowerPC units and port FreeBSD to it, people seem to think that's a good thing. And other people thought that was worthy of interest too. And so as of February last year, I've been working for the Isilon storage division of EMC as a FreeBSD developer. Who are they, you may ask? EMC you may have heard of, or you may not have. Most people have heard of the companies they own, the two big ones being VMware and RSA. No, I don't have anything to do with them. So the Isilon storage division started out as a company called Isilon that EMC bought around 2010. And they make clustered scale-out network-attached storage. I see you all know what that is. Good, good. So working backwards through that, most people know what network-attached storage is. Instead of it being a storage area network where you're talking blocks over SCSI, you're talking over NFS, CIFS, Samba, HDFS, iSCSI, HTTP, FTP. I don't think we support Gopher, but if anyone paid us to, we probably would. We're scale out. Most people have some idea what that means. Scale up means you take a small when your small thing is too small, you replace it with a bigger thing. Scale out is when your small thing is too small, you add more things to it, and it makes a bigger thing. And as part of that, you kind of need to be clustered. In our case, we use clustering for several things. One is for fault tolerance. Obviously, we need to be able to survive disk failures. We need to be able to survive node failures. But one of our key selling points is that despite having all of these sometimes disparate nodes in a cluster, there's only one file system. We share out one file system that's aggregated through the storage of all the nodes in our cluster, which is why, of course, we call our software 1FS. 1FS runs on nodes which are, they're nothing you wouldn't be alarmed to see in a data center. They're fairly standard PC server kit. The interesting stuff in them is we've got some internal hardware that helps us do our fault tolerance, and we have InfiniBand interfaces for our cluster backend fabric. So what is 1FS? Based on the introduction, you can probably guess 1FS is FreeBSD plus stuff. What kind of stuff? Well, there's the kind of stuff that I can talk about in high level, being our file system and cluster backend code, which that's about as far as I'll go into that. We have some tweaks to user land. We have our administrative interfaces. But we also have a whole bunch of local modifications to FreeBSD to help it fit better with what we do. Some of those we upstream, some of them we don't. The reasons for not upstreaming, like we're not going to upstream the file system code, obviously. But we do upstream some things, like we have certain test support infrastructure we've paid people to develop, we've either developed internally or paid people to develop things that we need that have been contributed into mainline FreeBSD that we then use, and various things like that. And I can go into a list of those or point out some examples if people are interested. So all of this is a long-winded way of introducing the fact that we maintain a divergent fork of FreeBSD. So we have to maintain our own FreeBSD codebase as distinct from the mainline FreeBSD codebase. You may do things like that too. Most of you, I hope, are not insane enough to do that with an entire operating system, but so we do this because we need to have local modifications and stuff like that. We need to have tweaks that may not make sense in the broader FreeBSD community, but that make sense for us. So the rest of this talk, I'm going to be talking about a bunch of strategies you can use to maintain local forks, and sort of also incorporating war stories of a project that we've been working on. So to introduce the first strategy, don't. We need to, for a whole host of reasons. You may not. I mean, if you're using jQuery in a JavaScript project, or you're using requests in a Python project, You probably don't need to diverge too much, and if you do need to, your best approach is to try and upstream the change immediately. So if you're sitting there thinking, oh, I've got this brilliant thing, but I don't know if I'll use it, ask them. Because in a lot of cases, Kenneth's a nice guy, I've met him twice. The guy who maintains requests for Python, he's awesome, and he will talk to you and help you with whatever you need. But so yes, with that out of the way, we had a problem. When I joined Isilon back in February, the first project that I got put on is solving a problem, which is our FreeBSD is old. So yes, we maintain a divergent fork, but our fork is of FreeBSD 7 point something. Point something is, I'll get to that. FreeBSD 7, to give you an idea, 7.3 came out in 2010. FreeBSD 10 is coming out this year. So yeah, 7 point something comes because broadly our code base is about 7.3, but there's a bunch of backported stuff that we've pulled in piecemeal, and then there's all of our local modifications. So that just makes it even weirder. So strategy number 1, don't do that. If you're tracking it, track it. Don't let yourself get behind. So we needed to fix this, but not just fixing the fact that we're on an outdated version. We needed to fix it as permanently as we could. Now, obviously, that doesn't mean we can sort of do a project that runs over X amount of time and then go victory and we're done. We need to answer a couple of questions, one of which is, what version do we move to? But the more important question is, how do we stop it happening again? Because the previous approaches that we've taken had been to go from, say, FreeBSD 5 to FreeBSD 7. And that took, a year or so, or 2 years probably, once you include release engineering, testing, verification, all the stuff that we have to do before we push it out the door, because people pay a fair bit of money for our products and they don't want it to break. So we had the version discussion, we had the how do we stop it happening again. Eventually we sort of went, okay, so the reason why FreeBSD has these stable branches that they work off is for release engineering. They want to release a FreeBSD X.0 that is hopefully as solid as possible. We also have release engineering internally, so why don't we just do that? We can take FreeBSD current. If we have the right sort of setup in place, we can avoid revisions that we know from the community to be dodgy. We can back them out if we need to, but if we're generally tracking FreeBSD current, we're getting the latest features we can get, and we can stabilize them in our own way, possibly finding bugs. If we find bugs, we can upstream fixes, which is great. So strategy number 2, don't track branches. A lot of software projects these days don't have that kind of stable branch release model that FreeBSD does, but if they do, don't do that. Stay on the main line, especially if you're doing your own release engineering, because that means that you can be a better community citizen, you can upstream fixes, and everyone wins. So we decided we were going to be developing tools and processes for tracking FreeBSD current over the long term. And we were going to be upstreaming as much of our code as we can to minimize diffs. As I mentioned, we have a bunch of internal changes. We have failure points, which are ways that we can instruct the various kernel functions to break. We use that for testing. That's been upstreamed. We have various fixes to locking code, scheduling code, various performance fixes, a lot of which we upstream directly where it doesn't touch code that's internal to us. And that just minimizes the amount of divergence we have to track when we're bringing in new changes. So strategy 3 sort of follows on, upstream as much as you can, which kind of follows on from strategy number 0 too. Just if you can make the change for them that fixes something that your upstream project has, fix it. So yeah, sounds great. How do we do that? Our code checkout, last I did it, was about 5 gigabytes. For a number of reasons. So we had to sit down and go, right, we want to get up to FreeBSD current and we want to then track current following on from there. How do we do that? So our first approach, we took what I call the pile it all up approach. We took FreeBSD current, we took our internal code base for our file system, cluster backend and other stuff, We shoved them all together and we started working through it. And by working through it, I mean, try and compile it. Oh, that broke. Okay, we'll fix that and try. Oh, that broke. And then eventually it compiles. We've got a kernel. That's great. Okay, it crashed. So on and so forth. And eventually your manager starts going, are we there yet? At which point we suddenly realized, not only do I know that we're not there yet, I don't know how far away from there we are. This is kind of a big ball of string and we're just following it through there. And so when your manager starts saying, look, I need to tell my manager how much longer this is going to take, you have a problem. But the question that finally sunk it was, how do we test it? You've just given us this big pile of mud and we need to make sure that there's something good in there because all of our high-paying customers, and there are some very high-paying customers, want to make sure that this isn't going to break when we deploy it. So we sat back and went, okay, so this isn't working for us very much. So let's move on to another approach. So we sort of went back and we tried to identify where the earliest point at which we could say we diverged from FreeBSD. And so yes, we don't use Git. Like all modern, forward-thinking organizations, we use Subversion. We use Subversion for a number of reasons. Mainly because, well, FreeBSD uses it for a start, like any modern forward-thinking organization. And we have a whole bunch of tools that are built around it. And, instigating changes in an organization is kind of hard and all that kind of stuff. So anyway, but what we really wanted to be able to do was a git pull from FreeBSD, or a git merge, git whatever you want to call it. We wanted to pull the revisions in from FreeBSD, apply them to our local code base, so we ended up with those changes applied to our thing, modulo the changes we needed to make within those changes. This is sounding like Git now. But the problem that we first ran into was Subversion can't track merge metadata between repositories. Subversion is great at merging internally. It has no concept of the idea that there might be a repository over there that you want to pull changes into your repository from and then apply them. So, like all good programmers, we got PySVN, we wrote a Python script, we looked at this Subversion merge info property format and went, that's really easy, why aren't they actually doing this themselves? And wrote a script that would pull in revisions from FreeBSD, apply them to our branch, and then track that in effectively a Subversion merge info property that we created ourselves. Which brings us to strategy number 4. Fix your tools if your tools aren't working. That led us into the world's ugliest rebase. Because as I mentioned previously, we were on stable 7. For those who don't know how the FreeBSD release model works, you have head. Off head comes stable X, and off stable X comes release X.Y. As I mentioned before, we were tracking a branch. Don't do that. So we were on stable 7. We had to get ourselves back onto head. And so we started applying revisions from head from about the branch point of 7.3 and kept going. But of course, that meant that we had several different types of merge conflicts to deal with. We had merge conflicts that arose from our own local modifications. We had merge conflicts that arose from the fact that we may have backported things from FreeBSD 8, FreeBSD 9, and they conflicted. And then we had merge conflicts that resulted from backports to stable 7 that were not the same as the change that was made to head. We got there. So how did it all work out? Well, the tools worked great. We made a couple of modifications. We added the ability to do range merges, because one of the things we found that was slowing us down was the fact that Subversion, being a sterling, wonderful tool, was really bloody slow. And so committing a revision at a time was just taking us forever. So we went to 10, and then we eventually went to 20 revisions at a time, just to speed things up without sacrificing the ability to bisect and work out which revision changed what. because part of the reason we went with this approach was that by progressing forward in a sort of measured approach, we could see how far we needed to get, which solved the "are we there yet" problem. But we could also run our test rigs over everything and periodically. I mean, we couldn't do it with every change because the shortest test cycle we have goes for about 1.5 hours, and that's after you've spent an hour building it. The longest one goes for nearly a day, I think, or longer. But we could actually test things as we went. That, in the end, it worked well, except for the fact that we ran into one huge fun problem where a layer 2 change completely blew apart our cluster backend fabric, but we won't go into that. So yeah, we're not at FreeBSD current yet. We've been working on this process for probably about 6 months now, of which 9 weeks of work got us up to a code base that roughly resembled FreeBSD 8. And the rest of that has been trying to deal with various things like our cluster backend network stack blowing up. So what next? Well, we obviously need to get to FreeBSD current. We're planning to make that this year. But then we also need to work out the processes involved in meshing the FreeBSD development process with our release cycle. Because strategy 5, don't stop. If you're going to be tracking it, track it. If you're not going to be tracking it, then don't start. Unless you know that that code base will suit you forevermore going forward, then you're going to be tracking this. You're going to have to maintain your modification all the way along, which is why we get back to strategy 0, which is if you don't need it, don't do it. So yes, in conclusion, just to reiterate, don't get behind. Don't track the branch, track the leading edge of development unless you don't want to do your own release engineering. Upstreaming is your friend for a great many reasons, one of which is just being a good citizen of the project. If you want that project to continue and be viable in the long term, you need to be making contributions. And this is part of the reason why Isilon decided to get a lot more engaged with the FreeBSD project. Is the FreeBSD project is one of those things that has periods where everyone starts going, I thought they were dead. And something seems to bring it back, and this time around I'm very happy to say that Isilon was one of the groups that basically realised that and said, right, well, let's make this keep going because we use it and we need it. Some tools can be better than others, but most can do what you need, possibly with the aid of a bit of Python. And don't stop tracking it if it's important to you, because if you stop tracking it, you run into the first problem of getting behind it. And that would be it. Thank you.
Now, some questions for Benno. If possible, could you please repeat them for the benefit of the people watching on live
Certainly.
and recordings afterwards?
Yes.
So, you've got a Subversion repository.
Yep.
Previously, it's got a Subversion repository.
Correct.
How do you track which change sets you have already looked at and decided you don't want to use?
We would market it, the question was, FreeBSD has their Subversion repository, we have ours, we have tools that track which revisions we have merged. The question was, how do we track revisions that we are not going to merge? The answer is that we would probably mark them as merged. Just edit the merge info and say, we've got that one, don't do it. Yes?
I'm in a bit of a similar situation with a Linux fork.
Yep.
It's almost worse than what you've described. How do you actually...
I fear for your sanity.
Well, at least we've still got Git.
Yes?
Right. The actual question is, how do you convince the manager types that this is a good thing? Because from my point of view, my managers are perfectly happy with the product that we're shipping right now. To then me saying I want to track Linus' tree is just work for nothing.
In our case, it was our performance team. Being in the storage business, performance is one of the big metrics that will sell units. Our performance team said, FreeBSD, the in development FreeBSD 10 has a bunch of performance improvements that would make our lives better. Additionally, the underpinnings that are there would allow us to internally develop even more, add more performance to things. Mainly between 7 and 10, FreeBSD has fine-grained a lot of its locks in a bunch of places. There's been recent effort towards fixing locking in the disk and I/O subsystems, which for a storage company, kind of important. And so it was really them driving it that pushed this through. That and the fact that people were realizing that we're 4 years behind, or 3 years behind at that point, in terms of what we could be using. And so I think it was just, what I'm glad about, I wasn't actually involved in the decision, but the decision to track current over just trying to jump up to 10, I think was a good one for us. I don't know what your organisation does in terms of its own internal release engineering and stuff like that. So it's really whether there are features in the in-development versions of Linux, that are needed to sell what you make. Where a sell could be download in terms of open source projects or whatever. You need to have a compelling reason.
Russell was next.
Okay, so FreeBSD is using Subversion.
Correct.
And obviously they're a completely different organisation with their own internal politics.
Mm-hmm.
You're inside EMC and are using Subversion.
Mm-hmm.
There's obviously a strong engineering push at both. A lot of God would like to use something other than SVN. Is there actually an internal political reason why you're not using something like Git SVN to manage this?
So the question was sort of internal political discussions over the use of Git versus Subversion in both EMC and in the FreeBSD project. Some of our engineers do use Git SVN against our internal Subversion repository. That's fine. We've got, our wiki has instructions on how you set that up and everything. In terms of why we don't use Git as our internal version control system, it's really just, you need to convince enough people that it's worth the effort. And no one's managed to do that yet. In terms of FreeBSD's use of Subversion, I watched a lot of that debate go on. And, open source projects are wonderfully collaborative, respectful, tolerant organizations. Basically, the only reason we ended up with Subversion is because a person by the name of Peter Wem, who is awesome and frankly kind of scary at some points, decided that Git, Mercurial, and all the others could generally talk to Subversion as a backend, and that he had root access to the cluster.
It's also an easier transition from CVS.
Yeah, FreeBSD used to use CVS, and if you think Subversion is bad, I invite you to try CVS. And I think that's time.
Well, on those fantastically depressive answers to that last question, time to wrap up. Thanks, Benno, for that.
Thank you.